As promised, let's go ahead and talk about how to identify conjugate acid-base pair when given just two chemicals, right? So this is for Chem 101 students or anyone else. This is regarding their Chapter 7 assignment, and it's actually number 55 from the homework. So we're going to identify them, and we're also going to identify why they may not cut the mustard on by actually being classified as an acid-base pair. So this first one, so remember, we're going to put a little reminder here. Acid-base pairs, ooh, we found a dead marker, didn't we? Acid-base pairs, conjugate acid-base pairs must differ by only a proton. And what do I mean by that? Only by an H+, right? So one of them has to have a hydrogen and a plus in there. It has to be more positive. So let's dig in and look at a couple examples. Can this be a conjugate acid-base pair? The answer is no, because they differ by more than just a hydrogen, right? So there has to be not only just a hydrogen difference between them in the formula, in the chemical formulas, but there also has to be a positive charge difference, right? It might be a -2 and a -1, it might be a -3 and a -2, but you see how those numbers are only one charge difference. These both have a charge of 0, right? They're not ions, and these differ by an oxygen here. So these can't possibly be considered conjugate acid-base pairs. So no. How about the next guy? Well, they differ by hydrogens, that's for sure, but they differ by 2 hydrogens. So there's 2 here. So there's too many difference between the two. So can these be a conjugate acid-base pair? The answer is no. Has to be differ by only a proton, one of them. How about the next one? You will have to know this for exam, so remember this is hydronium and this is hydroxide. What do they differ by? They differ by 2 hydrogens, right? You have to add, if you add 1 hydrogen to this, you would get H2O, and then you'd have to add another hydrogen. So both of these differ by 2 H+. So they can't be it, right? Oops, sorry, I'm being messy today. Sorry, guys. Both of these differ by 2 protons, 2 H+, right? If I added 2 H+ to this, I would get this. If I added 2 H+ to this, I would get this. It's not what I need. How about the last boy? So it's got to be him, right? Let's see if we got lucky. So do these differ by only 1 hydrogen in the formula? Correct. And if I were to take this and add an H+, what would my charge be now? Remember this -1 right now? If you add an H+ to this, the charge would become neutral, and it is in fact neutral on this one. Correct? So if I took HSO4, so you could even picture it, HSO4 minus plus an H+, right? That would equal H2SO4, right? The hydrogens would combine and the charges would combine. So check mark, happy, yippee. So it's this guy right here. So it's this option. So just keep practicing. This should be one of the good ones for the exam. These should be the ones where you go, oh, I hope half the exam is this, because these should be pretty straightforward. Good luck.